In this video we are going to create the particles. In order to do it, let me give you an example. Let's say that this is our robot and we want to find it in a 2D region. So our robot has an X value, Y value, but it also has an orientation value. Now the orientation of this robot is different from the orientation of this robot. And you can think of it as a vacuum cleaner robot that can move forward and backwards. In our example, if the orientation is 0 degrees, the robot can move along the x-axis. If the orientation is 90 degrees, the robot can move along the y-axis. And if the orientation is, let's say, 30 degrees, the robot can move along this line. So our robot has three parameters. It has X, it has Y, and it also has orientation. What we are going to do is to create particles. And particles mean different gases. Each particle will have three parameters. It will have X, Y, and theta, orientation. Now bear in mind that we can have two very similar X and Y particles, each with a different orientation. So the upper particle has orientation over here, and the lower particle has orientation over here. So how do we create those particles? We need to sample them from a uniform distribution. Each particle will have three parameters. X is between 0 and X max. Y is between 0 and Y max. And theta will be between 0 and 2 times pi, or 360. So this is what we have. Each particle is drawn from a uniform distribution and evenly spread across the region of interest. Now, what are we going to do? Let's say that I know that my robot moved 1 meter forward. So I know that from here, it moved to here. What am I going to do? I'm going to take each particle and move it 1 meter forward. In our example, this particle over there will move to here. And this particle 1 meter forward will move here. So basically, what I'm going to do is to take the action function, the moving function, and activate it on each particle. If I know that my robot turned 30 degrees clockwise, I will take all particles and turn them 30 degrees clockwise. Later on, we will see a method to distinguish between particles, to see which particle has higher probability and which particle has lower probability. But in the meantime, what we are doing is just creating the particles. Another thing that I want to mention. Sometimes in the region of interest, we will have constraints. For example, a wall. A constraint is a place where the robot cannot be. The robot cannot be inside the wall. So let's say that I know that my robot moves 1 meter forward. This is a particle over here. And I know that if this particle moves 1 meter forward, it will end up inside the wall. So I know that this particle is improbable because if it did move 1 meter forward, I will end up inside the wall. What am I going to do with it? Probably assign a 0 weight or 0 likelihood to this particle. So basically, this is how to create particles. And you create particle with X, Y, Z, yaw, pitch, and roll. So if you want to do a full 3D localization, position, and orientation, you will need to sample 6 different parameters: X, Y, and Z, yaw, pitch, and roll. In our example, we kept it very simple: X, Y, and orientation.